Ever felt like you're trying to navigate, I don't know, a bustling city without a map? Especially when it comes to tech systems.
Oh, yeah. All those complex connections, it can be a lot.
Exactly. How do all those moving parts actually talk to each other dynamically? It feels, well, overwhelming sometimes.
Mm-hmm.
But you're in the right place. This is the deep dive. We give you that shortcut to being really well informed
That's some surprising facts thrown in.
and hopefully just enough humor to keep you hooked. Today, we're diving deep into something core in Kubernetes: labels and selectors.
Right. Often underestimated, but so crucial.
Yeah, this isn't just about definitions. We want to uncover that ingenious mechanism Kubernetes uses, how it intelligently connects everything.
It's the magic behind the scenes, really.
Our mission here is to pull out the most important bits from our source, Kubernetes labels and selectors, linking services to pods,
So by the end, you'll really get how services dynamically find pods.
and why this seemingly simple idea is just fundamental for managing big, complex apps with agility.
It's powerful stuff.
Seriously, if you want to really get Kubernetes, its dynamic nature, its flexibility, understanding labels and selectors is, well, it's foundational.
Absolutely. Once this clicks, everything else makes more sense.
Yeah, a lot of other pieces just fall into place.
That's right. So we'll break down what they are, their purpose.
Especially how they get rid of those brittle static links.
Exactly. And how they work together, their critical role in routing, scaling, policies, the whole shebang.
Okay, let's unpack it. Let's start with the basics. Core definitions.
Yeah.
Labels and selectors in Kubernetes.
What are they exactly? Okay, so at their heart, labels are like smart tags, key value pairs.
Key value, like name.value.
Precisely. Things like app.frontend or nv.production, you attach them to Kubernetes objects, pods, services, deployments, whatever, to identify them, organize them.
Got it. Tags. And selectors.
Selectors are the filters. The intelligent part, maybe, they're expressions that match those labels.
So they use the tags.
Right. Services and controllers use selectors to dynamically find and pick out specific resources that have the matching tags.
So it's a tag and filter system. Brings order to the potential chaos.
You got it.
That makes a lot of sense. Like maybe tag all your backend microservices and then have a way to say, okay, show me only the production backend ones.
Exactly that kind of thing.
But why? I mean, why were they invented? What's the deep problem they solve in distributed systems that makes them so essential for Kubernetes?
Well, the big problem is how brittle static addressing is, especially in dynamic environments like Kubernetes.
You mean like hard-coding IP addresses?
Yeah, exactly. In a traditional setup, if a server's IP changes, boom, you got to manually update everything pointing to it. It's fragile.
Nightmare fuel for operations.
Totally. Labels and selectors completely sidestep that. They enable what we call dynamic linking.
Dynamic linking, yeah.
It lets services and controllers discover and connect to pods on the fly, even as pods get created, deleted, or their IPs change underneath.
So the IP changing doesn't break the connection.
Nope. It also unlocks scalability, because you can target groups of pods based on shared labels, not just one specific instance.
Okay, scale easier. Makes sense.
And for big clusters, it's just crucial for organization and flexibility. You group resources logically, manage them without these rigid, hard-coded dependencies.
So it's about letting the infrastructure adapt to the app, not forcing the app onto rigid infra.
That's a great way to put it, yeah.
That static versus dynamic linking difference is huge. Okay, before we go deeper, let's just level set on terms. We'll be throwing around a few Kubernetes words.
Good idea.
We're talking about a pod that's the smallest thing you deploy, right? Holds containers.
Yep, one or more containers.
Then a service that gives you a stable way to reach those pods.
A stable endpoint, using selectors.
And the whole thing runs in a cluster, which is just the set of machines, the nodes running your stuff.
Right, your set of nodes.
Right.
And you'll mostly interact with this using kubectl.
The command line tool.
Yeah. And all these configurations, your labels, your selectors, they get processed and stored by the API server.
The brain of the operation.
Kind of, yeah. The central control plane component. Understanding how labels and selectors weave through all this, that's key to seeing the power.
Okay, here's where it gets really interesting, I think. How do they actually work in practice? Let's dive into labels first. The anatomy, the purpose.
Right, labels. Their job is to attach meaningful metadata. They describe what an object is for, its environment, maybe its version.
Like context.
Exactly, context. Always key value pairs, like we said, app.nginx, nv.production, simple format.
And you can put them on anything.
Pretty much any Kubernetes resource. Pods, deployments, services, even nodes themselves. And a single resource can have multiple labels.
Oh, multiple, so you can get really specific.
Yeah, for fine-grained categorization. And critically, you can update them without messing up your running apps.
Non-disruptive updates. No.
Very nice. Common uses. Identifying pods for an app, like app.offService. Separating environments, .nv.dev, nb.prod. Tagging versions, .version.v2. Or roles, like role.databasemaster.
It's like this universal dynamic tagging system for your whole infrastructure.
That's a good way to think about it.
So super flexible, non-disruptive metadata tags, bringing order. Okay, now selectors. How do they actually find and query these labels?
Selectors are the query part. Their job is finding resources based on those labels. This lets things like services and replica sets target specific groups.
Okay, how do they query? Are there different ways?
Yeah, two main types. First, equality-based selectors.
Yep.
Simple matches, like app-my-app, looking for that exact key-value pair.
Straightforward.
Then you have set-based selectors. These are more powerful. They use operators like noten or exists.
Ooh, okay. Like SQL where clauses almost.
Sort of, yeah. For example, in dev staging selects pods in either dev or staging.
Gotcha.
Or tier noten backend database would grab everything except those tiers.
Powerful filtering.
Very. And their real power is enabling that dynamic targeting. These selectors automatically adjust as pods come and go. You don't touch anything.
They just keep track.
They keep track. You define them in the spec.selector field in your YAML, usually for services or controllers.
Okay, this feels like the real aha moment brewing. How do labels and selectors actually cooperate, work together? This dynamic duo, as you called it. This is the core, right?
It absolutely is, the core of Kubernetes flexibility. Here's the flow. First, you label your pods in their metadata. Describe them with key value pairs.
Step 1, tag the pods.
Step 1. Then a service comes along. Instead of looking for fragile IP addresses, it uses a selector. It just says, hey, route traffic to any pod that has this set of labels.
Like app.frontend.
Exactly. This makes sure traffic hits the right application instances through a stable endpoint. Even if the actual pods underneath are changing IPs, scaling, failing, doesn't matter to the service endpoint.
Wow, okay, so the service is decoupled from the individual pod details.
Totally decoupled. And similarly, controllers like replica sets or deployments use selectors to manage pods. They ensure the right number of replicas with specific labels are always running. The controller knows I need 3 pods with app.backend, and its selector finds them or creates them if needed.
Ah, so it uses the selector to know which pods it's responsible for.
Precisely. And the brilliance is the automation. Pods get created, deleted, rescheduled. The selectors automatically update their targets seamlessly. Includes new ones, excludes dead ones, based purely on labels.
So a service targeting app.web always finds the web pods, whether there's 1 or 100.
Doesn't matter how many or which specific ones are running right now. That's the magic. Continuous auto-discovery.
That is incredibly powerful for keeping things running smoothly. Okay, let's ground this. Practical use cases. Where does this dynamic duo really shine? First up, linking services to pods. Give me a real-world scenario.
Okay, most common one. Imagine a web app. Multiple pods running the front-end code, all labeled app front-end.
Makes sense.
A Kubernetes service, configured with selector.app.frontend, automatically routes incoming client requests to any of those front-end pods. It provides transparent load balancing.
So it spreads the traffic.
Spreads the traffic, yeah. Without you manually setting up load balancers for specific pod IPs, the beauty is the service dynamically targets the right pods. So your app can scale up, scale down, handle pod failures.
Without the client even noticing.
Exactly. Zero disruption from the client's perspective.
Okay, cool. What about scaling applications? That can get complex fast. How do labels and selectors help there?
They make scaling almost, well, effortless compared to the old ways. Consider a deployment. Its job is to ensure, say, 3 replicas of your app. Back-end pods are always running.
Okay, desired state. 3 pods.
Right. The deployment uses its selector, app.backend, to track exactly which pods belong to that group if one pod fails.
The deployment notices it's missing.
Yep, and automatically replaces it, ensuring the new one gets the right label. If you decide to scale it to 5,
Just change the desired count.
you change the replica count in the deployment spec. The controller sees it needs 2 more pods with app backend, spins them up, labels them correctly. It maintains that desired count dynamically.
Without labels. Managing that manually across potentially hundreds of pods.
A nightmare, a configuration management nightmare.
Okay, beyond linking and scaling,
Hmm.
You mentioned organization. It sounds like labels are just fantastic for tidying up messy clusters. I've seen some that look like digital junkyard.
Oh, absolutely. It's salvation for cluster hygiene. Labels give you this super flexible way to categorize resources without changing their actual configurations.
How so?
For example, just label pods, nvdev versus nv.prod. Now you can perform targeted operations,
Right.
like maybe run debugging tools only against your dev environment without any risk to production, or apply stricter network policies just to prod.
Target operations based on labels.
Exactly. It's
Yeah.
like having a perfect dynamic filing system for your whole infrastructure.
Nice. And finally, a really critical one today, policy enforcement, security.
Yes, hugely important. Selectors enable incredibly precise targeting for policies. This boosts security and helps manage resource allocation.
Give me an example.
Sure, you could create a network policy that says only services with the label role. Front end are allowed to talk to pod's labeled role.
AppB.
Defining allowed communication paths.
Precisely. Based on labels. This enforces strong security boundaries, ensures only authorized components talk to each other. It helps build security in from the start.
Okay, so we've seen the use cases, how they solve real problems. Let's peek under the hood a bit more. How do labels and selectors actually interact with Kubernetes deeper down? What's happening behind the curtain?
Right, it all starts with your YAML definition
Those
files.
are config files.
Yeah. When you define a pod, you add labels under metadata.labels. For a service or deployment, you put the selector under spec.selector.
Simple enough.
Then you apply that YAML, maybe using kubectl apply. It gets sent to the Kubernetes API server.
The control plane brain again. Yep. The API server validates it, makes sure it's correct Kubernetes syntax, and stores it in the cluster's distributed database, usually etc.
Okay, config stored. Then the control plane takes over. How does that become actual routing for a service?
Correct. So components in the control plane are always watching the API server for changes. The service controller sees a new service with a selector.
It's watching.
It's watching. And it continuously identifies all pods currently matching that selector. It keeps an updated list of endpoints.
Okay, knows which pods match. Then what?
Concurrently, there's a component called kubeproxy running on every single node in your cluster.
Kubeproxy on each machine.
Right. kubeproxy also watches the API server for service and endpoint information. It takes that list of pod IPs matching the service selector and dynamically configures the node's networking rules.
It sets up the actual network paths.
Exactly. Usually using things like iptables or IPVS on Linux, it makes sure traffic sent to the service's stable IP gets correctly routed and load balanced to one of the pods in that matching set.
Wow. Okay, and for controllers like deployments.
Similar idea. The deployment controller watches the API server. It uses its selector to see how many pods with the right labels currently exist, if the count is wrong.
It fixes it, creates or deletes pods.
Precisely. It acts to match the desired state defined in the deployment spec. And even the scheduler, which decides which node a new pod runs on, can use labels for placement rules.
Like only run database pods on nodes with SSDs.
Exactly, that kind of constraint, often using node labels and selectors. And the key thing, again, is the dynamic updates. Pods get created, deleted, rescheduled. These selectors automatically adjust their targets in real time.
So the system constantly self-heals and adapts.
That's the goal. And as a user, you leverage this too. You use kubectl, getpods, slapp, myapp to easily filter and see just the pods you care about.
Right, using labels for your own management tasks. It really sounds like labels and selectors are the silent architects of Kubernetes efficiency. Why are they so effective? What makes them work so well?
Yeah, it boils down to a few key things, I think. One, dynamic linking. We've hit this hard, but it's crucial. Services controllers always target the right pods, even as IPs change or pods get replaced. No manual reconnections needed.
Saves tons of time and errors.
Huge time saver. Two, flexibility. You can group and manage resources in multiple ways at once using different labels without hard-coding dependencies. Think multi-tenancy, environment separation, easy versioning.
Makes complex setups manageable.
Right. Three, scalability. They let you efficiently organize and target resources in massive clusters without needing to track thousands of individual instances manually.
Essential for large scale.
Absolutely. And finally, four, they're the backbone of automation. Kubernetes uses these selectors internally to automate load balancing, scaling, rolling updates, policy enforcement, all the complex stuff that makes Kubernetes powerful.
So they enable Kubernetes to do its job automatically.
Pretty much. They make life much, much easier for developers and operators.
That automation really is the game changer. Okay, to wrap up our understanding here, what are some best practices? How should people use labels and selectors effectively?
Good question. First, definitely use descriptive labels. Make them clear, meaningful .app, .inventory service. Invest staging. Something that tells you immediately what it is.
Avoid cryptic stuff like L1X.
Please avoid that, yeah. Second, make sure your selectors are precise. You want to target only the pods you intend to target. Avoid overly broad selectors that might accidentally grab the wrong things.
Specificity matters.
It really does.
And I imagine consistency is key too, especially across teams.
Oh, absolutely crucial. Standardize your labeling schemes. Agree on common keys like app, NV, version, team, whatever makes sense for you. Use them consistently across all projects.
Prevents chaos and confusion.
Exactly. Makes the whole cluster much easier to understand and manage. Also, really leverage labels for filtering with kubectl. Get comfortable with the L flag. It's super powerful for querying and debugging.
You use the tools you have.
Right. And finally, maybe obvious but important, version control your YAML files. Your deployments, services, pods, all those definitions with their labels and selectors should live in Git or similar.
Track changes, collaborate, roll back if needed.
Exactly. Infrastructure as code principles apply here strongly.
Okay, so pulling it all together, what does this all mean for you, our listener?
Well, I think the bottom line is labels and selectors aren't just some minor feature. They are absolutely fundamental to how Kubernetes operates.
The core model.
The core model. They're the dynamic backbone. They let services link seamlessly to pods for load balancing. They empower controllers to manage resources for scaling, for security policies, everything. They decouple your application from the raw infrastructure underneath.
Yeah, this seemingly simple idea, right?
Yeah.
Key value pairs, some query rules, but it unlocks just an incredible amount of flexibility and automation.
It really does.
It's what lets Kubernetes handle these huge, complex applications so efficiently, without relying on those old, brittle, static identifiers that break the moment anything changes.
Like an IP address changing or a pod spinning up or down.
It's kind of the secret sauce for making infrastructure resilient and dynamic.
Could have said it better myself.
I know.
Exactly. And maybe a thought to leave with. Considering this power, this dynamic linking that labels and selectors give you,
Yeah.
how might really understanding this mechanism influence how you approach designing or maybe troubleshooting cloud-native applications, even thinking beyond just Kubernetes itself?
Ooh, that's a great question to ponder. How did this pattern apply elsewhere? Well, we really hope this deep dive gave you some surprising facts, maybe a clearer path to understanding this crucial Kubernetes concept.
Hope it armed you with some good knowledge.
Yeah, knowledge to make your next step in cloud-native development just a little bit clearer. Until next time.